explain what centrifugal extraction is, how it works, and the role of its main components, including practical examples of its industrial applications. Have you ever wondered how industries efficiently separate immiscible liquids like oil from water or purify metals from solutions? Centrifugal extraction is a powerful technique that combines centrifugal force and solvent extraction to achieve fast and effective separation. In this video, we'll explore the principles behind centrifugal extraction, how it works, and why it's so widely used in various industries. Let's jump right into it. So what is centrifugal extraction? Centrifugal extraction is a process used to separate different substances, usually two immiscible liquids. But the catch here is there's a desired substance in one liquid phase which we are trying to extract into another. So the main difference between this and the use of a centrifuge is the extraction of the valuable components in the liquid phase. So here we have a centrifugal extractor, a cross-sectional view of a centrifugal extractor or contactor. I know it looks like a lot, but I'll try my best to explain how each part works and what each color code means. Okay. So let's start with the inlets. Here we have an inlet for the lighter phase and one for the heavier phase. So as I said before, there are two immiscible liquids in which one contains a valuable component that is desired, and we are trying to extract that component from that phase. So either the component is in the heavier or the lighter phase, it doesn't really matter. But we have two inlets, one for the lighter and one for the heavier phase. So we put the lighter phase liquid in here, and it drops down here by gravity, of course. And you put the heavier phase in here, and it drops down. We call this zone the annular mixing zone. So please bear in mind, this is a cylinder. This whole thing is a cylindrical form. There's the outer casing, which forms a sort of a skeleton, yeah, for the whole machine. And there's this inner cylindrical form, which is the rotor, which is going to be mixing the two phases together. So there's a passage behind this rotor all around. So once the liquids are put into their inlets, they come into contact around the rotor. Okay, so once the liquids enter the annulus, which is here and here, they come into direct contact with the outer surface of the inner spinning rotor, which is this. So you see the liquids are coming into contact with the outer layer of the rotor. This is one of the most important parts of this machine, because once they come into contact and the rotor starts, it ensures efficient mass transfer, because it yields fine dispersion with high interfacial area, and it causes rigorous mixing of the two phases. So this here is the annular mixing zone. After the rigorous mixing, the phases which are now mixed, they are in the color green, they drop down by gravity and they enter the rotor. This is the rotor inlet. So you can see the liquids joined around the rotor, and by gravity they have been pushed into the inner side of the rotor. This is called a diverter disc, and the main function of the diverter disc is to force the phase into the outer side of the rotor. So you see, this is the liquid, the mixed phases is being forced to the outer side of the rotor. So as the rotor continues to spin, it causes centrifugal force, a buildup of centrifugal force inside it. And this centrifugal force pushes the heavier phase to the sides of the rotor, leaving the lighter phase in the middle of the rotor. This is a mixed phases. This is a mixed phases. Okay. So here we have a little passageway for the lighter phase to flow through to its outlet, hence separating the liquid. It goes here. Mind you, this is it's in a cylindrical form, so it goes around and all passes through the lighter phase outlet. And the heavier phase, which has been pushed to the side of the rotor, also comes into here. We call here the heavier phase, which is basically a storage tank for the heavier phase. And here is its outlet, the heavier phase outlet. And here is also a lighter phase which also stores the lighter phase as it's being pushed outside. Yeah. You have the separation vane, which divides the rotor. It also prevents mixing of the phases once they reach the final third of the rotor. So that is basically how the centrifugal extractor works. Those are the most important points in it. One might ask, why mix the two phases if we are trying to separate them? What you should bear in mind is that in this centrifugal extraction, we are trying to get a desired component from one liquid to the other. So it is necessary for us to mix the two phases in order to transfer this desired substance from the other into, yes, from the other. Exactly. There are quite a lot of uses for centrifugal extraction in various industries. One use is the uranium extraction in hydrometallurgy. The process, uranium is leached from ore using an acidic solution, creating an aqueous phase containing dissolved uranium. This solution is mixed with an organic solvent, maybe kerosene or any other chemical extractant. Yeah. And as I said before, the mixing ensures that the desired substance, which in this case is the uranium ions, move into the organic solvent, which is the other phase. So afterward, the centrifuge separates the two liquids, leaving the uranium-rich phase and the aqueous phase behind. We also have separation of oil and water in petrochemical plants. So in this process, in petrochemical plants, water mixed with oil or hydrocarbons is separated using centrifugal extraction. For instance, during crude oil processing, water and oil emulsions are mixed with emulsifiers and processed in centrifugal extractors. There are several other industries where centrifugal extraction is used, but to sum it all up, the basics of this whole process starts with the liquids entering the rotor and mixing in the annular zone. Let me project that here. Mixing in the annular zone, the heavier phase moves outward, the lighter phase stays in the middle, and the separation vane directs each phase to its outlets. So the lighter phase comes out here, the heavier phase goes out there. And depending on which phase had or needs the desired substance, we can get it afterwards. So thank you very much for watching the video. See you next time.